Hey, what's up, Ziguanas? This is day 12 of the 30 Days of Z Coding Challenge. Join me as I apply over 2 decades of professional programming experience and around 15 years of code teaching experience to master a new language. The name of the language is Zig. My name is Dusan. Welcome to Zignited. So yesterday I did functions and structs, more structs than functions, because functions, as they are described in documentation, they are basically jumping through some basics and they are just showing a little bit more advanced things, and I didn't want to learn those and play with these before I just go first through the basics, so that I can understand first the basics, how the functions work in Zig. So that's why I kind of skipped over a lot of documentation about functions. Then I went to structs, and today I'm going to continue with enums. But first I would like to find some examples here that I remember from yesterday about functions where they used structs, because I did not go through structs at that point of time, so I did structs later. I believe this is the example. Yeah. So let me just do this example with functions and structs, and then I will move on to enums. Okay, so let's take first these two, and let me prepare things a bit here. So this is from yesterday, and in the main one, let's see what they want to do actually. Okay, this is testing, I don't care. This is the part that they do, and just to double check, this is, yeah, this is the one that I missed, and after it, type in first. I did this yesterday, I believe. Yes, I did. So basically I will just do this example, and then I will move on to enums. Okay, so let's do that here. And first of all, let me see what they want to do. Okay, this is pretty basic struct called point with x and y coordinates, which are i32s. Then they create this function, which is outside of the struct, foo, which receives the struct as a parameter. And then the return type is i32. And then what they do is they just summarize the x and y and return. Okay. And let's see what they say. Here, point could be a reference or a copy. The function body can ignore the difference and treat it as a value. Be careful, very careful. Taking the address of the parameter, it should be treated as if the address will become invalid when the function returns. Aha, so this is something that looks like borrowing in Rust. I mean, the main part of it. So they, if I understood correctly, they are not enforcing this. They just advise that you should treat it as such. So you still have a full control, I believe. I will know more when I play with it later. But looks like that for now. Okay, so I will not do that. I was just curious about what they were explaining. So this is pretty straightforward. And then here, what I will do, I will call this function, and it should be 3, right? Yes, because here 1 and 2 are the points, and then here we just sum them up and return. So should be 3. Let's do that here. And let's say here, result equals this, and I will just remove this. What is the error? Where 19 here? Okay, what did I do wrong? No, it's actually one part missing here, right? So just let me see, this closes that one. Yeah, I deleted by accident, I think, one parentheses. Yeah, result is 3. Okay, this is nothing special, so I just wanted to, I didn't want to do it yesterday. Here, I probably even then I've seen that it's a simple thing, but I didn't want to use something that I haven't touched yet. So here they create the struct, and I did structs after I started with functions, so that's why I didn't want to go. Okay, so now I can move on to, where are the enums here? Wait. They are before. Yeah, here. Okay. Do they have some intro here? No. Let's see what they do. They jump right into the examples. Okay, they declare an enum as a constant, and it has 2 values here, okay and not okay, or 2, yeah, I would say values for enum. I don't know what is the correct term for what they are. Fields, yeah, fields. So declare a specific enum field, const c equals type okay. Okay, then let's copy these, and I will just go through them let's do one by one. So we'll just start simple with this one. And again, so I remember from yesterday that I had some problems making an internal function, so a function inside of a function, so here in main. So I guess it's possible. I still haven't read the entire documentation, but the part that I've researched, it did this. So they always had functions outside of a function, so no nested functions. So the same with struct. I remember when I had, so it worked fine when I had struct here, and then when I used it, it was fine. But the moment I created the struct with the function inside of it, the function couldn't see the struct itself, the type that you create. Basically not the type, so the type is struct, but the variable that you create inside. So it didn't see anything if it was here in the function main, but here when I copy pasted, actually, and when I cut pasted here, it was fine. So that's why I've probably paste here. Maybe I'll just try in a second down there again, because this is not so complicated. There aren't any functions inside like with that struct yesterday, and this is enum. So maybe it will even work here, but just in case, I'll start like this. And let's print it out. So type. I'm so like paranoid when I see that they name this like type, and it was also what they used, another word that I thought it as a reserved word a few days ago. And actually it's not, obviously, because they wouldn't do it. But I kind of like when I see something like this, I go paranoid. Okay. So this type result, and I guess it will work if I put any only here. But let's try. So this will probably break. Or maybe because they're simple. Yeah, they're simple enough. I'm blind. So they're simple enough so that the formatter can understand them. But if I say any, will it be the same? Yeah, the same results. Okay, they are simple. Then let's see the constant here. So that one I'll do here inside of main. And let's print this. So again, I'll start with the simple thing. Result, yeah. So not result, but let's say C. Play type OK. Okay, makes sense. So play type here and play type OK for a specific field. Okay, let's see the next example. And let's see what they say about it. If you want access to the ordinal value in Enum, you can specify the tag type const value enum. So here, unsigned to. Okay, 0, 1, 2. So in this case, they will literally match, like the word here, that the field name will match the numerical value, because you unsigned integers start with 0. And it's interesting in this case that it's actually U2. So it's not 8, it's not full byte, it's just 2 bits, which is basically enough to have 0, 1, and then 2 would be 0, 1, 0 in binary, right? So we can technically create number 3 as well, and it would fit here. I'll actually play with this. I just want to run it first. I want to see what happens if I assign too small. I guess it will break, but just to see. Okay, so let's say value here, and let's print it out. And yeah, by the way, now I'm trying what I was mentioning before. So here it's outside of main, here it's inside. So I guess it's going to work just fine in this case, but just to test that part as well. Yeah, works fine. So now let's try to do one more here. And I don't know if I have to use the comma. I mean, it's probably a good idea anyways, because of the later working with the same code, but I will also test if I can actually omit this comma. But let's do one step at a time. So this should be still be big enough to hold all these 4 values. So 2 bits for 4 values should be enough. No problems there that I can foresee. Yeah, okay. And then let's try one more, which I think should break because it cannot fit into 2 bits. Yeah, it makes sense. And what they say, enumeration value 4 too large for type 4. For type not 4, but for type U2. Yeah, so as soon as I do one more bit, it should be fine, right? And this time it should break if I do more than, so 5 is the last that can fit, and then 6 should break again. Okay, that part makes sense. But what if I do this? If I delete the comma, will it still work? Comma. Yeah. So I guess it's just, so of course this one will break the code if I delete, but I was just curious about this one. Okay, that one works. In here, we don't specify how they call it, tag type. Yeah, the tag type. So here it's unspecified. And then I guess because they say if you want access to the ordinal value, you can specify. So they don't say you have to. Maybe there is automated assignment in the background. So I don't know. And let me try if I can change the type here to, let's say, I. And let's do I8, doesn't matter. I just want to see how this will work. So because they start, I8 starts with -128, right? So then the ordinal value, yeah, it looks like it works fine. So then I guess what happens in the background is that it will start with -128. So let's see if they have some examples to get these ordinal values. Yes, this is exactly that. Value 0. Oh yeah, they just like mention it by name, nothing special. I thought maybe I have to do something specific. So let's do now in this case 0. And I guess it will be -128 if I'm not mistaken. If I say the type is I8. So now that's the question. Do they start with the lowest possible value of the type, or they have the default value that tries to be 0 or something. Let's see. So value dot 0, for example. And here I'll do the same just to be more clear what we print. What we have. I don't see. What am I missing? So they equal it to 0 here, but instead I just get the field. What is the value of it? Why this? I can do equal 0 just to see the truthfulness. Okay, this is formatter probably, because I'm not using the correct formatter. Okay. Let's say main value and comp time int. And why? Because I changed the type. Let me see if I put it back to you, just to have the same example like they have, just to see if that will work. Okay, this is another thing. Let's delete 4. Yeah, it's still comp timed, so I just wanted to double check because I forgot about the unsigned integers, if they are also comp timed. I mean, literal here. Yeah, this is it's not related to the type that I changed. Yeah, I forgot. This is about this literal here, not the comp time int. Okay, why in their case they can compare? They use this, yeah. Okay. I completely did not see. I overlooked that completely. Then I don't need this equal part. I just want to see the value. Int from Enum. Yeah, this is the first time I've seen this built-in function. Okay, that makes sense. Now, if I switch back to, let's say, I8, what will be? Still 0. So the type, if I select a different type, they don't care about the lowest value of it. They just start with 0. They try to start with 0 in both of the cases. Yeah, okay, it makes sense. It's more natural than I thought. I thought maybe because what they specified here, that you can select the type, I thought maybe you can also influence on this, let's say, the integer value of the ordinal, how they explain this is maybe better. Yeah, it's ordinal, so it cannot, if it's order, then it cannot be, so can it be negative by math definition of ordinal numbers? I don't think so. But anyway, so it makes more sense now. It's not integer value of, it's ordinal. I haven't heard, like, I know like you can be the first, the second, the third in something, but I've never heard in math they say like minus first. Maybe I'm wrong. You can override the ordinal value. Literally what I was saying, but this is you manually doing it. So let's see. So it's not forced by the type, but you can do it manually. Okay, let's try now doing this for that other one. So it's called value to write, yeah, and let's say 1,000. Yeah, okay. Let's see what the next. Okay, they test here. You can also override only some values. So this should be then 0. They actually display. I don't have to even think, but I wanted to think for myself. So 0.8, then what's the third one? They start from 0 here, but the moment I change this, they take the next value that is by 1 greater than the last one that I manually overwrote, which makes sense because they cannot think about if I'm going to take some number. For example, here I could have said 2 and then left this one and this one empty. So if they were not going from 2 to 3 here, but let's say because this is 0, if they tried 1 and then 2, that would be a conflict. So it makes sense that they just like continue from, they go back here. I'm curious what would happen. So this is like very interesting. So I will try to do the same example, but to actually provide a bit different numbers that I see if it's smart enough to just like deal with these potential problems or conflicts. So let's do what they did. Yeah, it's a new enum, and here I will do the same. No, actually it's easier to A, B, C, D, E. I will just do it myself here. And I can comment these. I don't need them anymore. Yeah. So here and here. So it's value 3a. And then they have B, C, D. Not V, is C. Or what's the problem? Unused. Yeah, I forgot. I have to comment all these. Wasn't thinking. Yeah, 0, 8, 9, 4, 5. Okay. 0, 8, 9 after 8, 4, and then 5 after. Okay. But what if I say here 2 and then I delete this? It will just 3, 4, 5, I think, yeah. But what if I decrease after? Well, let me just think what I wanted to do. So yeah, basically I cannot trick it in that way. If I decrease, it will just continue. But let's try like this. If I say this one equals to 2, then I let it run here to 3. Then I say this one is 0. Then let's see what will happen after 1 here. Or maybe I'm not allowed probably to decrease. Yeah. No. So it broke here, not because it decreased here. Yeah, because they also decreased here. I forgot for a second. So yes, it will break. So it is not smart enough to skip over that value. But if I do this, then it should be fine. Because I'm printing it, yeah, I forgot to print. Let's just comment for a second. Yeah, okay. And then I guess if I just do any number, there is no reason why this wouldn't work. If I just skip from, instead of, not here, I wanted to do E equals, let's see, 100. So then this one, then no reason for this not to work. And am I printing it? Yeah. Oh, okay, this is the size problem because it's U4. I did not pay attention. Yeah, everything logical. Enums can have methods the same as structs and unions. And methods are not special, they are only namespace functions that you can call with dot syntax. So it looks like they copy pasted the same explanation for struct and their methods. Okay, let's do this part here. Let's do it here. And then the testing part, this one here, down here. Comment out those. And let me first see what they want to do. Club, spades, diamonds, hearts. So playing cards. And the function is clubs, takes itself the same const enum. It returns boolean, and it returns if the self equals to suit clubs. Okay. So it receives a suite, so basically the same type of where it is at the moment. It is inside of the enum. So the self will be this enum here. And then it just like takes whatever instance you send and checks if it's clubs. That's why it's called these clubs. Then they create an instance which is spades, so not clubs, should be false. Let's see this part here. And yeah, in this case I don't care about this integer from part. Yeah, it's true. And I guess if I change to clubs, it will be, no, why it's clubs? Ah, not, yeah, it's asking if it's not. Okay, okay. Yeah, because now it's inverting. So book is, because it is clubs and it's negating true to false. Okay. An enum can be switched upon. We'll skip this because I haven't touched switch. And why I haven't, I think I just wanted to do first the if condition. And that's why, and then I think I completely forgot about them. Let me just double check. Or if they use something exotic. And a is what? Yeah, it's an integer, unsigned integer. Yes, so it's nothing specific that, okay, here they switched to switching, not, no pun intended. They switched to switching a struct. No, it's a union. So it looks like, yeah, it's a struct. Tag union. Yeah, okay, this first example is struct, this second one is union. So maybe I saw this and that's why I skipped, but this is something that I could have done before. So maybe tomorrow I will step back and play with switches. And I don't know where the unions came from. Union here, it's after enum. Ah, okay, so in this order, switch is after the enums. Okay, maybe that's why I did not work with them yet. Haven't worked with them yet. Okay, let's move on. Yet this one I will skip because switches come after. Info can be used to access the integer tag type of an enum. Okay, this is related, so let's do this one. and I haven't seen them explaining what can be the tag type, so I guess any integers. It wouldn't make sense that you have a float enum. So, I mean, this is just sanity check, so I've never seen enum being anything else but integers in the values of them, the tags, how they call them, or the ordinary values, not the tags, the tag type, but the ordinary values of enums are always integers and unsigned integers. Yeah, I can try it here, the negative. This is just like for curiosity, not that I expect it will work, but here where I did, let's try just like to compile. If I say minus 100, just to see if it can be negative. And these clubs, did I leave them? Yeah, okay. Just to see if it will compile, or it will tell me you cannot have negative value for the enum. Yeah, it did compile. I think I clicked run. Yeah, and if I do, can I make this float? Or it will break. Like how it's called, F. Right, F. No, how it was called. My mind. Let's see, floats. F, yeah, it's F. And do we have? No, we don't have F8, only 16. It works, but will it actually work if I use the literals that are having some decimal points? It works. Well, this is crazy. Let's see. Well, maybe I missed this in some other programming languages, so I've never seen enums having any other values than integer ones. Okay. Why it breaks when I use it? Aha, maybe the compiler. So if I don't try to use, the compiler doesn't even compile this part or something like that. If I don't use them, it's okay. But the moment I try to use, then it will report. So at compilation time, yeah, integer tag type. Okay, now it makes sense. So basically it will not let you do this, just like the compiler will not complain until you actually try to use that enum. So during the compilation time, it will just like see if you're specifying the type, but it will not check if the type is actually one of the allowed ones. Or maybe that's just like case for floats. Maybe it will say if I tried another type that is, I don't know, a pointer or something, maybe they will also refuse even if I don't use. This was just like hacking things. Of course, I actually don't intend to do something in the real world like this. Just playing. Okay, where we were stopped here, not structs, enums. Yeah, this is the 1, 2, 3, 4 part that I copied. Then they want to see what is the enum tag type with this. Okay, let's do that. So I want to print this inside. What they say. Index values runtime, no. Wait, what? Oh, enum. Type info small. Okay. So I literally copy pasted from here. Ah, okay. Oh, I missed so many things. Okay. So this was a chain of. So this is built-in method. But the next thing, what is this? Maybe built-in field on the thing that this method returns or something. This built-in function, not method. And then or parameter that they send into this built-in function. Something like that. I don't know what this is. But anyways, let's try to run. Yeah, this works now. And I also want to check something else. So if I do delete this part here, I will get the same error. I just want to read one more time what was the error. The error was values of type const built-in type enum field must become time known, but index value is runtime known. Okay. First com time because of this field. Com time int. Okay. What if I specify the type like what we did here? If I specify, now the type is known, the compilation time. So if I say whatever, 8 for example, will this fix that issue? Waiting for server. Okay, so it's not this, it's something inside in the type enum field. Maybe this is that enum field. Yeah, so this is not what I thought it was, so it doesn't have to do anything with this directly, but something more deeper. Okay, the next one, type info tells us the field count and the field's names. So type info, the same one that we use here. It's just like they use it for. So then obviously this type info brings you a lot of things. So this part is the same. But then inside of that, whatever it returns, some struct, I guess, that struct contains not only the tag type, but the fields, which contains length and probably some other things here. Because if it were just length, they would probably put it as .length directly, not fields length. Okay, so let's try that. And what's the next one? They are trying to see if the field 1. Okay, this is interesting that they use the square brackets to index the field with the ordinary number if the name is equal to 2. So I will just print it like always. I'm not going to expect yet. I will start using the error handling as soon as I go through the basic things. Okay, so I wanted to print 2 more times. For the first time, this one, this part. And for the second, this. what did it say? Format slice without specifier. Ah, okay, formatting part. So I guess this is for from here. And let's say any. Did they say what's the line? I guess it's this one, but just to see how the compiler tells me. Okay, this is internal for mother. Local internal. Internal. Yeah, they don't say here in this stack. Our stack, they don't say where, but I guess it's here. Let's see. Yeah. Why I get this when I want to get a name? Wait. So the small. This is the enum. Length is 4. That's correct. What they were expecting here to see 2. Yeah, why I don't get 2? Fields 1 name. Let me copy paste one more time this, and I want to see if I by accident I deleted something. Ah, okay, understand. So they are, yeah, because I didn't copy this part. So what I guess I have here is, yeah, that's why I was also thinking why I get this error that I'm getting that I tried to format the slice when I actually wanted to get the name, which is basically this part here. But yeah, because that name is technically stored like a slice because it's not a string. There aren't any string types in Zig. So this is actually TWO, and this is just like when you say equals, it will try to see this as the slice of U8s, and it will compare it to this if it matches the TWO. So I can basically test that if I do the following thing. If I say, for example, I expect this is T, and I'm going to test it by saying T under quotes, and here I want to see it. Yeah, if I say C, it should display T as a character, but if I leave it, it should be a number. So let's see if I'm going to get 116, and I wanted to delete or comment out. Yeah, I know that I will get an error. Yeah, it's 116. So basically, if I do the same for the W and O, string unit format rest, not any. Ah, okay. Thank you, Robert. Yeah. Yeah, I figure out now that what it was happening. So it's been a while since I played with these low-level things. So I think the last time I did it, it was when I learned C and C++ and C on my studies. But it's interesting for a change. Yeah, this is 0.14.1. Hello, Neil. Yeah, let's run this thing. Yeah, so these numbers are matching this, and like Robert said, if I say S, should format it as a string. So I should see 2. Yeah, perfect. Thank you, Robert. Let's see the next. Tag name built-in method gives This is like zero terminated const, right? Representation. What is this? I think this is zero terminated array, I believe. Let's see, try expect mem, blah blah. Let's try doing this. 1, 2, yeah. So this is tag name, then 3. Yeah, I just wanted to do this. Just thinking about this equal how it works. So it compares this part and this part as U8s, I believe. Okay, so here let's see what we will get. Tag name small 3. So for the 3. And this is as string now, right? So let's see. Yeah, so then it means this is one way to do it directly, and this is another way, but just like if you go through a different path. Okay. We'll skip this part for now. Or C ABI compatible enum. Okay, this is C related to the C language integration. I will skip for now. Enum literals allows specifying the name of an enum field without specifying the enum type. Okay, let's see. Okay. They have this dot auto. This is the auto here. I didn't see. So color 1 is color dot auto. And here they specify the type. This is the difference. So here they just say it's a color, and here they say dot author. So it's smart enough to understand that it should look inside, and here it's directly specified that it's the color dot auto. Okay. Yeah. So they allow specifying the name of an enum field without specifying the enum type. So that's the case here. Let's just copy paste this quickly. I will do it here outside of main. And let's test this. And I can comment out these things before. So I can do this time comparison just to see the result, and let's run. Yeah, everything clear. Let's see the next example. Switching, yeah, I will not switch. I didn't do switch. Switch, and we come to union. Okay, so then I guess I will stop here because I don't want to start a new topic. It's already been about almost 1 hour. So I guess tomorrow I will do a union. They are the next in line here. And I will move on from there. Yeah, I think that's the plan for tomorrow. Okay, thank you guys for being here today, and see you tomorrow. Bye-bye.